Hi, I'm Katie Williams from May South High School and the Girl Scouts of the Kansas Heartland, and today I'm going to cover the periodic table, its history, and explain some of the numbers on the periodic table. Here we go. In the mid-1800s, scientists were starting to figure out, like, okay, we have these elements, and we have gold, and we have helium, and we know that these things are indivisible. They're not, we can't break them down into simpler things. And they were starting to figure out things like, okay, the density and the weight and whether or not it's electrically conductive and whether or not it's malleable, what it reacts with, what colors it can come in. And so they were starting to try and organize these things, and people were putting together lists. And there's actually a guy in Germany who had like a cylindrical structure that he had written the names of the elements on the outside and kind of had them organized together. And the guy who actually got published and ended up creating the structure that we all know and love was named Mendeleev. And one of the things that he did, well, he looked at it and he said, I'm going to list them by atomic number, which is the number of protons in the nucleus. List them by atomic number, but I'm also going to put them in order of properties. So like we have here the alkali metals, which are super reactive with water, and over here we have super unreactive elements, the noble gases, and in between there's transition metals. These things are all similar. We have copper, silver, gold. They're all in the same period organized like that. And there's also trends, increasing electronegativity or ability to attract electrons goes this way, and all these different things, and he put them in that order. Another thing that he did, which was very clever, this is something that almost nobody else thought to do when they were putting together their lists, is he left blanks where things that hadn't been discovered belonged. So he said, okay, we don't have anything with atomic number 43, we don't have anything with atomic number 75, but I'm going to leave blanks there. They're underneath manganese, and I'm going to call them echimanganese and V-manganese, meaning one below manganese and two below manganese. And he was right. He predicted that these elements would be here, and they are. They found technetium, they found rhodium. Mendeleev even predicted what their atomic masses would be to within 2 significant digits, which is very impressive for the 1800s. So we have the periodic table. Over here, I'm going to explain sort of what these blocks look like. This is the chemical symbol, so we have letters Tc for technetium. A lot of symbols coincide with their English names, like H for hydrogen and C for carbon, etc. But there are a couple weird ones, like tungsten is a W, which actually stands for the Latin name for tungsten, wolfram. And then there's, over here we have Pb for lead. Pb stands for the Latin name for lead, plumbum, which actually comes from the same word as plummet, because lead is a very heavy element, and at the time when it was named in Latin, people believed that heavier things fell faster than lighter ones, which of course we know is not true. We also have the atomic number in this corner up here, so for technetium it's 43. And then we have this weird number over here, this 98.9022. And a lot of people, the first time they look at the periodic table, they think, okay, well, we have the number of protons right here, so this must be the number of neutrons. But it can't be, because you have 98.9072. That's impossible. You can't have 0.9072 of a neutron. They don't split that way. And so what this number actually is the atomic weight, so what we call the atomic weight, the weight of the nucleus, essentially because electron weight is basically negligible. The weight of a proton and a neutron are nearly identical, so we call that an atomic mass unit. And so we say we have 98.9072 atomic mass units, which still doesn't make sense because you still can't have 0.9072. Well, that number comes from something called isotopes, and isotopes are elements or atoms of an element that have a different number of neutrons. So for instance, we have hydrogen, which just has one proton and no neutrons in the nucleus. We also have hydrogen, which has one proton and one neutron in the nucleus, and there's actually even a hydrogen isotope that has one proton and two neutrons in the nucleus. So the number of neutrons changes, and that makes it a different isotope. There's all sorts of naturally occurring isotopes. One of the most famous ones is carbon. Carbon is normally carbon-12, but there's a less common isotope of carbon that's carbon-14, which is what we use for carbon dating and radioactive dating and things, but it's a radioactive isotope of carbon. So when we go to put this number together, we're looking at all the different isotopes of an element and sort of percentage-wise by how they occur in nature, we average them. So, mostly hydrogen is just one proton, no neutrons, but there is some one proton, one neutron, and even a little bit of one proton, two neutrons that occurs naturally. So when we go to look at the atomic weight of hydrogen, it's an average by percent of how often they occur. So you end up with about 1.00795, which is, mostly the lion's share of the naturally occurring hydrogen had no neutrons, but then there's that little percent that bumps it up from an atomic weight of 1 to an atomic weight of 1.00795. And so there's radioactive isotopes, and there's also stable isotopes. Interesting thing about technetium here that we're looking at, technetium is the lightest element with no stable isotopes. And it's all the way over here at atomic number 43, and the rest of the elements that don't have stable isotopes don't start until down here at 85, 86, and so on. And so that's one of the reasons that this originally named Eki manganese was so difficult for them to find, is because it was radioactive, and radioactive elements, they're unstable, and so they send off particles and sometimes waves until they find themselves in a state where they are stable, which is always as a different element. So it was not being technetium, it would turn into something else and we wouldn't find it. So that's the periodic table and its history. Pretty short video.